Do you want to have a look at a hot end? Yeah? Come on. It's episode 4 and we're talking about 3D printing enclosure for our Hybrid EDTracker. But rather than just diving in and 3D printing it, which would be quite a boring video, we're going to look at 3D printing in general for the home user, just in case it interests you. Maybe you're thinking about buying a 3D printer, or you've bought one and you're trying to figure out how to use it, how to make the most of it. So it kind of follows on from the previous video about 3D design. We're going to take a look at kind of home-based 3D printers here. So there's lots of industrial 3D printing techniques. It's a very advanced kind of science these days. We're just going to be looking at basic, what they call fusion deposition modeling, FDM printers, which all kind of work the same way. They take a filament here, a thermoplastic filament. They heat it up as it goes into the hot end, hence the start. Go into an extruder. Heat it up really hot, about 200 degrees centigrade, extrude that plastic out onto a bed, and then you build your object up from the ground upwards. Yeah, all of the printers kind of work the same way. I'm not going to turn this into a review of printers or a comparison, because I've only got experience of one, which is this one, my one. It's an Ormerod 2. It was made by, or the kit was provided by a company called RepRap Pro. Here you can see they've gone under now. I think they don't make these kits anymore. But it was an open source design. Great little printer, to be honest. It's a shame it didn't keep going. But I think the iPrusa and all the kind of other models, all built and sold as a complete printer, kind of took off more really. But you could buy this as a kit and you could assemble it yourself. I think they sold all of their spares to RS Components. So you might be able to still get these from RS if you're really that fussed to get one. But they're all much of a muchness. So we're going to just take a look over this. Just a summary then of what we're going to go over in this video. So we'll go over the anatomy of this particular 3D printer. But like I said, it's kind of generic. It applies to all of them. We'll also have a discussion about how you could use it, whether you realistically need a 3D printer, whether you will make use of one. We'll talk then a little bit about software that you need to use your printer over and above your 3D design software that you would have used to design your models. We'll then go over some of my kind of techniques and tips that I've picked up over the years. I've had this about 3 years now, I think, that might be useful to you. And then we will start the print job for our enclosure. And we'll do some time lapse and all that kind of cool stuff, and show that printing and have a look at the final results. So let's look over the key components to a 3D printer then. Probably start off with the bed. So this bit is what obviously your model is kind of built up on. The size of it, coupled with the dimensions of your machine, will limit how big a model you can print. Yeah, this one's got a 200 by 200 millimeter bed. And 200 millimeters height as well. So that kind of defines the print area, the length of the axes and the size of the bed. That's probably about the biggest you'll get on home printers. That's quite a big one actually. A lot of the home printers are smaller than that. But that means this could essentially build a block 200 millimeters square on each edge. It's heated, so the bed gets warmed up by a heating element that just helps the model adhere to the surface. Yeah, so it depends what you're printing. If you're printing in PLA plastic, it heats to about 65 degrees centigrade. If you're printing in ABS, it has to get a lot hotter. It has to get kind of 95, 100 degrees centigrade, so it gets very, very warm. You can see it's got some yellow tape on it here. This is Captain tape, which you'll use to. You don't have to be honest. A lot of people get away without it, but that's just on there to give a nice finish and to help separate the model afterwards, basically. But yeah, you can see on this printer the bed moves in one axis. Yeah, so that is the y-axis, and then the print head moves for the other axes, for X and Z. So that brings us on to axes. Like I said, with this one is controlled. Let's get another camera going here so I can show you up in detail. So you can see here, if I push the bed over here, you see we've got some linear guide rails here just to kind of help control the movement. And then we've got a rubber drive belt coupled to a stepper motor here, and that controls the sliding of the bed in this axis, which is actually the y-axis. Likewise then, if we come up to the top here, the print head, I'll move this printer around so we can see it a bit better. So here's the print head, and this is on the x-axis, so you can see there's another drive belt here, another motor here, controlling the axis moving in that direction. This stepper motor here, by the way, this is operating the extruder. We'll come on to that in a second. And down at the bottom here, there's another motor you can see tucked away here. That's twisting this threaded rod, which is, if you can just look carefully, you can see that's adjusting the height of the head. Yeah. So that's how we get our 3 axes of movement. We'll come on then to the print head itself. So the main components here, you'll see right at the tip here, there's a stainless kind of tip, and there's a very tiny hole in there, which is obviously where your material is extruded out of. This block of aluminium has got a heater in it. Gets very hot. So this is what's affectionately known as your hot end. There's a temperature sensor in there to control the temperature, so it monitors itself, understands what temperature it's at, heats as it's needed. The fan is really there to obviously regulate the temperature of that print head, but it also blows air out across the model and cools that plastic as it comes out, so it kind of cools the material. You can see here there's a thing called a Bowden tube, which is basically the guide tube for your filament. So I've cut some filament off here, but you can see it kind of goes into the machine here. This motor drives a hobbed insert, so like a little insert with ridges in it, that grabs that plastic and pushes it down the Bowden tube and into the hot end. And it's that pushing it into the hot end which then coupled with the 200 degrees centigrade obviously, melts the plastic and forces it out of the tip here to create the model. And it's all very specific about the speed that this pushes through, the diameter of the material, the diameter of the head, to get an accurate kind of print. Yeah. Otherwise then there's not really a lot more to this. There are some limit switches, or there's one limit switch just down here you can see. If I move this, you might just be able to hear the click. So you can just about hear that click, I think. And that just allows the machine to understand when this y-axis has reached its limit. And it uses that to do a thing called homing, which we'll come on to later. There's also, under here, another sensor just here on the carrier for the print head. This is a distance sensor, so it's detecting the distance down here. And it uses that to home the z-axis. And it also uses it to home the x-axis as well. What it does is it kind of scans across the edge here, and when it drops off the edge of the print bed, it knows it's at that end, that edge as well. Finally then, obviously we've got the electronic-y part. So this is just a power supply, this kind of metal enclosure here. So that's just a regulated power supply. And then we've got all the kind of electronics are in this little part here. It's basically an Arduino style board. But it's got some interfaces here, so you've got a USB port if you want to wire this into your computer directly. There is a network port, which I prefer to use. So this particular, the Ormerod 2 introduced a network interface. So you can connect to this via a web browser and you can start and kick off all of your jobs that way. You also see there's an micro SD card here. That just stores configuration settings and all of your 3D instructions, so your print files basically. We'll come on to that. A cooling fan there, and that's about it really. There's not a lot to it other than that. You'll notice something I should just point out. This has just got a single print head on it, but what you can do is you can get machines with 2 or even 3 hot ends on them basically, so 3 complete extruders, so that you can load them up with multiple materials, different colours for example, and then you can print without having to change and reload material. Nice if you want to do multicolour printing. They basically would just duplicate how many print heads they have on them basically. The other thing that you can get is enclosed 3D printers. This one, as you can see, is out in the open. This would be very beneficial if you plan on printing in ABS. So maybe now is a good time to touch on the two main materials that these 3D printers work with. So the most common one is a material called PLA, polylactic acid. It's what this is. It's what I do 99% of my printing in. It's cheap, cost effective. It melts at a lower temperature, so it's easier to print with, easier to get kind of consistent results with, and it doesn't need heating up quite so much. It's not as strong though, so depends kind of what you're printing for. For most people, PLA is fine. If you want to print in ABS plastic, which we all know and love, then you have to heat that up a lot more. So PLA prints at about 195, 200 degrees centigrade. ABS, you've got to go up to kind of 240, 235 degrees centigrade. And more importantly, the bed and the print area has to stay at a higher ambient temperature. PLA, we're printing at about 65 degrees on the bed. ABS, we need to get up to 100 degrees, but also we need to keep the ambient temperature of the printer up, because what happens is when you print in ABS, if it cools too quickly, it warps. So where I was going with this was, if you plan on printing in a lot of ABS, an enclosed printer is much better because it keeps the temperature up inside the the print space and stops you from getting all warping effects on the ABS. So I would definitely, this prints in ABS, I have done it. The results aren't brilliant because of that problem with the temperature. Yeah, bear that in mind. You might ask, why would I be interested in printing in ABS over PLA? Well, ABS is slightly stronger, granted, so if you're making structural parts you might prefer it. But the other nice thing you can do with ABS is you can smooth it with the chemical process. Basically, if you do a Google, you'll find it, but you can dangle your 3D printed part into some acetone vapor. You put some acetone in a jar, heat it up, boil it, and the vapor will effectively melt the surface of your 3D printed part and smooth off all the print lines. So you can get quite nice professional looking final products in ABS, which you can't do in PLA. Yeah, so there we go. So the next thing to touch on is software. So you've got your 3D design file, yeah? You don't just pump that into the printer and it prints it, unfortunately. So 3D printers work just like any kind of CNC machine. They just take instructions from a very simple program, if you like. It's really a script that just tells the CNC machine effectively to move this axis in this direction, this distance, at this speed. And that's essentially all that a 3D printer is doing. So you need some software to create this script. It's called G-code. It's common to CNC machines, 3D printers. You need something in the middle that's going to create this G-code, and the G-code can be specific to your model of printer. Yeah, there are free ones out there. So the common one is called Slicer, with the E as a 3, so Slice 3R. That's a completely open source free one, and you'll probably start off with that. Certainly does the job. What we'll be doing when we start, well, we'll go into it now, is we'll be using a different one called Simplify 3D. That's right. It's a pay one, but one thing I just want to touch on with software is there can be a really big difference. Yeah, I was having some fun with Slicer when I got to larger print models. It just wouldn't reliably create the G-code. It would just screw up big style, and halfway through a print it would just start creating garbage instructions. It got so annoying that I just stumped up the 80 quid or whatever and bought Simplify 3D from a recommendation, and I tell you what, I've never looked back. The software, the quality of your print out of it has gone up, and it just reliably prints stuff far more. It's nicer, easier to use, quicker to generate code. You can, so if you're going to be doing a lot of 3D printing, you probably begrudge, like I did, having to spend money on more software, but Simplify 3D, worth every pound of its 80 quid. Does really good quality prints out of that. Okay, let's take a look at then the software process of getting our model to stuff that we can load in the printer. And yeah, I think what we'll do is we'll get that done. We'll load it all in the printer, and we'll get the job going. And then I'll talk about hints and tips while we've got some while we've got the prints going, and we'll do a bit of time lapse and we'll talk over that. Just try and keep the video as short as we can. I'm conscious that I go on a bit. Right, let's go over software then. First job on the printer here will be to clean the print bed. Make sure it's all nice and clean, not covered in any dust if it's not been used for a while.
but also any grease or previous kind of deposits of plastic. So best thing I found is a nice cheap and cheerful nail varnish remover. The key active ingredient in this is acetone. So yeah, just a bit of cotton wool, give the bed a good clean. I'm using this one. I think I just got it from Boots, a popular kind of high street chemist here in the UK. It's Q-Tex nail varnish remover. There you go. Smells quite nice, inoffensive. Over to our web browser then, we're going to use this to connect to the web interface on the Ormerod 2. You can see it's all kind of nicely presented in your browser, various controls here, but the key ones we're interested in are up here in the left. You can see heater and bed. And we're going to get the bed warming up. We're going to just get the heater started on that, because it takes a good kind of 10 minutes. So we'll get that going to 65 degrees. We'll get the head warming up as well. That warms up quicker, but the main one is to get the bed going. Yeah, that'll take about 10 minutes. So while that's going, we'll make a start with showing you how I use Simplify 3D, the software to do the creation of the G-code from the 3D model. Okay, so we'll launch Simplify 3D. Up it pops. See, you've got a kind of a visual representation of the print area, empty at the moment, but I'm going to drag. I've got the models on the STL files on my backdrop here. Just going to drag and drop that in, and there we've got our lid. Now at the moment that's kind of upside down. The way we want to print, I know it's the right way up, but as far as we want to print it, we want to print this upside down, because you see those cavities underneath are going to cause problems to try and print a suspended part like that. So it'd be print much nicer if we had it the other way around. So we can do this, place surface on bed, and we can click a surface, as you saw there, and just flip it over and put that down on the bed. So we'll print it that way up. That's much better, and we'll get a much better quality of print that way. Now we're going to generate our G-code file for the printer. So we have various profiles. We click this and we choose one of these kind of personal preferences. They're just profiles that I've set up for the type of material, whether it needs support or not, how much infill it needs, 15% in this case, which is just how it builds up the bulk of the empty space in the model. I've just got too many profiles chosen. Hold on. None. That one. Go. There we go. So now we've got this kind of nice little 3D representation. You can see I can drag this slider and step through the job. You've got this little visual representation of the job as it goes through. You can see it kind of showing it where the print head would move and building up the job. The colour kind of represents the speed of the head at that point. When you're ready, we can click on this icon, the USB one, to kind of print direct to the printer, but we're going to use this here to save it to a G-code file. I'm going to save that on the desktop. There's our G-code, and that's it for 3D Simplify 3D. We see we've got the file here on the backdrop. Let me just move that out of the way. There we go. It's generated a G-code file for us, and we're going to upload that to the printer. So we go back to our web interface, go to our files. It's got a kind of like a folder structure, so I've got an EDTracker one already. I'm just going to keep this organised, put it in there. Click upload, give it the file that you want. So we're desktop, Part Studio, that's it, G-code 1, top half. Click open, and that will upload it to the printer over the network. There it is, and it's now stored on the micro SD card in the printer now. Yeah, you can clean up all this. I'm going to get rid of this one, don't need that. Manage your files kind of thing. Yeah, and there it is. So one thing we need to do now is, you can see it's all warmed up. The head is nice and warm, the bed is getting there, it's almost 60 degrees now, it will be ready, but we've got to home it. So we're going to home the machine now. So you can see, I click the home all button, and you can see in the bottom right there the printer's going through this process of establishing where each of the axes is. So it knows the bed is in a certain position now, Now what it's doing is it's bringing the head down and it's using that distance sensor to gauge when it's just about to touch the bed. Now I don't rely on this, you'll see in a second. I kind of manually tweak it, but bang, there we go. It says it's happy now. It moves to the center of the bed, and then what I'm going to do is I'm just going to manually twiddle this and just get the clearance right. Back to the desktop then. You can see we're all homed, we're all blue here. Temperatures are good, the bed's good, so we can go to our G-code file and you just click the little green print icon and we shall set the machine off. What I'm going to do then is we're going to leave that going on a bit of time lapse. I'm going to talk over some hints and tips that I've kind of picked up over the years of ownership of this printer.
Quick thought on homing, in particular the Z-axis. So what I have found is that there's lots of automated process built into this printer to get the Z-axis height right. I've got to the point where, to be honest, I just do it by eye, and I can reliably do it by eye now. I can listen. As I bring the head down, as it starts touching the bed, the noise of the machine changes because there's some vibration. So I can hear that, back it off, and I've just got to the point now where I've done it so many times that I can kind of judge the Z height manually myself. I just literally turn the threaded bar with the motors turned off, and I just kind of get it where I want it before I start the print job. You can see here, this is what I'm doing here, is I'm just getting that height right before I start the job. Accuracy, don't expect, you probably get kind of 1/4 mil accuracy out of a 3D printer, I would guess. It's going to vary a lot on how much time you spend leveling the bed, which is another thing. Do spend some time getting the bed level. This has a kind of a 3-point adjustment, like a kind of triangle, which means you can adjust this. You should be able to get this perfectly flat, no problem. I kind of designed a little square that I can set the printer printing. I do that, I leave it going, and then I watch it and I look at the layer going down and I adjust it on the fly with the adjustment screws. There's one at the back, each corner at the back, and one center in the middle. And I find it easier to adjust the level while it's printing and kind of watch and get that. As it prints the material out, it extrudes and it splats out onto the table, onto the bed. And if you look at that, you can see where the height is wrong from one side of the bed to another. You want a consistent squidge, shall we say. So I just use that technique to level the bed, and just find that's far easier and quicker. If you've got a good eye for detail, you can do it nice and quickly that way. What were we talking about? Oh yeah, material quality. So you will have a variable experience with stuff that you buy off eBay, I will tell you. You might find a good supplier, you might not. You might stick with one supplier, you'll have one batch that's really good, and then you'll get a real shit batch. I would suggest that when buying material, like I said, mainly PLA I use. PLA is quite hygroscopic, so it kind of absorbs moisture. So if you're going to leave it in a high moisture content environment, it's going to go off pretty quick. My advice would be, don't necessarily buy the most expensive stuff if you're not going to get through it quickly. But don't buy the cheapest either. I kind of buy middle of the road. It generally lasts quite well. If you're going to be leaving it not printing for ages, unload it from the machine or snip it off and put it in a bag with some silica crystals just to keep the moisture level down in there, and put it away somewhere nice and dry. But yeah, if your material goes off, you will find you start getting pops and bubbles in your print. You'll just get random kind of inconsistencies in your print, and that's generally moisture or air gaps in the material. It could just be down to crap material. So I've heard stories of people buying pretty shit material from China and eBay and stuff like that, where the width has been completely inconsistent, just very low grade. So it depends what kind of quality you're looking for. You could buy some cheap stuff and have it as a muckabout material just for printing little test jobs maybe. But yeah, pays your money, gets what you get. I suppose my one key takeaway for reliable 3D printing is the first layer is everything, okay? So when you kick a job off, sit and watch that first layer go down, or certainly the first half of it. Whether your print succeeds or fails generally comes down to the first layer. If it doesn't adhere well to the board, if you're not getting that good squidge factor that I said, it's not going to stick on the board. Yeah, if your bed's not level, all these kind of things. Once the first layer's gone down, it tends to be plain sailing from there. One thing I touched on earlier, which I didn't answer, was whether you would make use of a 3D printer, and this is probably the crux question, isn't it? If you're a creative person, if you look at things around the house and you see a problem and you want to make a solution to it, and you've got the time, you'll make use of a 3D printer. Honestly, all around my house, every room has got something 3D printed in it. I'm looking at 4 Raspberry Pis that are all in 3D printed enclosures there, a programmer there. I've got a bracket up here for my HTC Vive light station that I just designed and printed just to hold it on my shelf up there. I've got a pencil holder up there that's full of pens and pencils that's 3D printed. A bracket on my soldering station to hold a fan. But, if you're going to be creative and make stuff, if you're not the person who does that, you'll buy it as a toy. You'll muck around with it for a few weeks, and then you'll go, oh, what do I do now? And you'll lose interest. You can download stuff off the internet, obviously, but there's only so much of printing other people's things that you do, I think, before it kind of loses its sparkle. So be honest with yourself. If you're kind of a creative kind of maker, hacker, then I think you would certainly make use of it. And you can do lots of very practical things with it. I know when I started, a lot of mates were like, what are you going to do with that? What a waste of time. Now, 3 years on, I've done some quite productive things with it. Parts for cars, like I say, all little trinkets around the house, all sorts of stuff. Been very useful. Definitely got my money's worth. In fact, I made money out of it. I printed some prototypes for somebody, and they were quite happy to pay for it. So, you can make use of one, but be honest with yourself. So after all of this, I'm sorry, it's a long video, I know. We finally have our 3D printed parts. That, as you can see, is the top, which I printed first. I'll get you some close-up photos of that. Here is the bottom. Now you can see the support structure, which I've left on here. Again, I'll put some close-up photos there. So the idea with the support, you just very carefully snap it off. It's quite loosely attached. If it's come out right, the 3D printer's kind of left it fairly loosely on there, and you can kind of gently coax it off. I'm going to do that with some pliers, maybe. Just snap it very gently. I don't want to snap the tail of this device. Hold on. There we go. Okay, there it is. So that's our idea. LED points in there, there and there. We need to test whether we've got a good hole through that. Let me get some wire. So here's the moment of truth. Is that hole all the way up there? Yes it is. Yes it is. Yeah, there we go. I've got to just get some tweezers just to pull the wire through there. But that's good. We've got wire. Wires will fit round there fine. Let's get the PCB. Let's try that. So here's our PCB. We'll just check that that fits in. Oh, perfect. Slots straight in there. Straight in. I can't believe that. And get to the USB connector there, and the lid goes on. That is very rare, to be honest, that the first print actually works. I'm quite impressed there. I could probably make the PCB slightly tighter, to be honest. It's clattering around in there a little bit, but I prefer that. I can put a little bit of hot glue in there. But yeah. Right, what we're going to do, let's park that. Next video then we'll assemble all of this, we'll do all the soldering, and we'll do the final testing, see how it works. Okay, so that for this episode is it. 3D printing done. Sorry for the length as usual, but yeah, Till next time.